No. 3, 2, 1.
Hello and welcome to Study with Street Science. We're running a little bit late today, and you might see that it's a little bit different today because I am joined by two of our fellow science presenters. On my left is Jess.
Hi.
And on my right is Jono. Hey guys. How you guys doing?
Fab. It's been a big day.
Has been a big day?
Yeah. It's been awesome.
I feel like we've been running behind a couple of minutes on every project we've been doing today, but
I'm used to running late, so it's perfectly on time.
It just feels completely perfect.
Yeah.
Okay, cool. So this is Study with Street Science, and as always, we unbox a science toy each and every week, whilst we listen to some tunes. But today we're not going to listen to tunes. We are just going to have a bit of banter,
Listen to each other.
mix it up. So we'll see how it goes. We'll see how it goes. As always, on the over here we've got a reference to what we did last week. So if you haven't checked out last week, it was International Talk Like a Pirate Day.
Yeah.
We had a toy. It didn't quite come together as good as I hope it would, but that's how science rolls. So we've also got behind the scenes here, who's our producer, our manager, and she is trying to work out some couple of different camera angles for us. So bear with us while we figure out our tech, and I think we're all good. But today, what are we going to be doing?
I actually have no idea, Ken. You've left it totally as a mystery to me. So I'm actually really excited. I love a good unboxing video.
Okay.
I'm a bit scared, I'm going to be honest.
Is it snakes?
Well, as always, I haven't even seen what's in here either as well. T is the one that packs our boxes. So let's see what we've got in our box. So get a bit of drum roll. What do you reckon, drum roll? Ooh,
What is that?
We've got two toys today.
Oh, wow.
Okay, we've got two toys. I mean, we've got twice the number of people. We've got two toys. So let's just pack this up.
Twice the number of people?
Twice?
3 times.
Right?
Toys? Is that a word? You can see it's been a long day here. I'm going to let you guys introduce. So,
Okay.
when you introduce, put it in this area here. So let's go with Jess. What have you got?
I appear to have a magnetic car black. Specifically car black.
And it does look like there's two of them. So I do feel like maybe
a magnetic
there's
car black
one
race.
toy that can each.
I hope we can race them also.
And I appear to have salt water clock.
Sweet.
Which is actually really exciting because I'm a very salty person, so I can run the time purely from my own personality.
And a late person, as you've professed.
Absolutely. So this is the best thing. This is like born for me. And in fact, if I didn't know any better, I'd think you guys were having a go at me.
No, that's not how street science rolls. That's all good. All right, so what do you reckon? I'm seeing that there's two cars here. So I reckon we give it up. One of us does a car each, and then the other person does the salty clock.
Mm-hmm.
Who wants to do the salty clock? Who wants to do the cars?
Oh, look, I definitely need to improve my time management skills, so I might manage the salt water clock.
And I'm definitely down for a car. So would you car with me?
I'll car with you. Okay, cool. All right. So we're going to start going. As always, feel free to put some tunes in the background while you're doing some study. It is a school holiday, so if you're doing study, good on you. Champion, 100% points. Now, these instructions are a little bit sometimes all over the shop. So sometimes, just like in science, things can go wrong, but just can be different, and we have to make things up. So feel free to take your time, read it. We typically give ourselves about 30 minutes to build a toy. So luckily, I'm just going to follow what Jess is doing since I get to stand out of the hot seat, even though I'm in the middle here.
I'm big on instructions.
You're big on instructions?
I am so big on instructions. If anyone ever buys anything from any IKEA-based or flat pack boxes, call me. I will very happily put them together.
Okay, you got it. Let us know in the comments if you need someone to come to your house and build some furniture. Jess is on call.
I BYO Allen key. I'm there for it.
She'll be there in 30 minutes. Let's get it going.
Guaranteed. Or your installation is free.
All right, so I'm gonna
on.
have a look at this as well.
Totally.
I typically like to just punch everything out. That's my system, but I'll each leave each of you to figure out your own system as well. But I just like punch it out and then go by the instructions. So
Choking hazard, don't eat any of the parts,
okay,
please.
that's a
Ken.
good point.
Yeah.
All right, so what we're also seeing here for the cars is it looks like you build two individual cars and each one has a magnet. And I
Mm.
believe,
They'll probably interact come the end with repulsion or attraction, is my
yep,
guess.
so usually at the end page of the instruction, it tells you how to do. So I reckon there's definitely some magnetic forces that allows them to interact in some way. So
That's pretty
Hmm.
sweet. I'm going to organize all of our parts.
okay, cool.
How are you going with your stuff?
So I think you'd be working on polar repelling, wouldn't it be? You'd probably have similar polarities on both magnets facing each other, so you move them towards each other and they'll push each other away.
That's right.
So it's
That is a
like
good
it's
point.
like a game of chicken that would never actually occur.
Yeah, I wonder if actually I remember for those who were doing the classroom takeover, we had some magnet
Yeah.
plan.
We did do some magnets. That was sweet.
Oh, I think I finally got rid of them. I do have iron filings though, which
You can test these.
so with the iron filings, I think they are responsible. So these react to magnets. So theoretically, if this is indeed a magnet,
Right.
should oh here we go. Can you zoom in and see that? Let's go on to the zoom cam. Oh wait, we need to zoom up even further because even you know what we need? We know what we need. We need Ken Cam.
Ken
Ken
Cam!
Cam. Let's see if Ken Cam's working. Here we go.
I know when I like building stuff, by the way, I like having a little dish. This is from my IKEA experience. A little dish to put all of your screws and things in so you don't lose them.
Nice.
FYI for future reference.
A dish. Okay, we'll have to bring some dishes to the next one. All right. I'm going to see if Cam works. Is Cam? We're going to check with it. Oh, Cam is working. Here we go. Let's get a zoomed in close up version of this. Okay.
Now, would you like me to hold that?
I'll leave you guys to it. I'm
Oh
building.
yeah. Can you move the magnet around?
Absolutely, I can.
Right.
Check that out. Oi.
Oh,
So we
pop
know the
these guys
magnet
out.
is working. It's like drawing the.
Now the other part of that is if I flip it over, I can actually push the filings around with the opposite pole, I think.
Oh, that's pretty cool. Check that out. So if we've got two magnets, I guess, because that's when here's the other magnet. How do they react when we put them together?
So if I do the two red sides, they're opposites. And that's an adhesive that it looks like they're going to be attached to the car. So they will not connect.
Okay.
They'll push each other apart.
Wait, did you see that? That was pretty cool. It's like flung
Do
that
that
again.
again.
Well, they're not opposite. They'd be the same.
They're the
Oh.
same poles.
Yep,
Exactly.
Ah, interesting. That's cool. All right, there we go. All right, so I'm going to be building two cars. I'm going to put the Ken Cam. Oh wait.
Don't hurt yourself.
Is it
I'm gonna put
can?
Ken. All right, I'm going to put the filings away, and I reckon I'm just going to.
Your stuff making sense there?
Yeah, I need to grab some acetic acid.
Oh,
So
okay.
you'll have to excuse me a moment. I'm gonna have to leave the studio to find some acetic acid and salt.
Luckily, we have chemicals out the back.
We sure do.
And you know, you probably have acetic acid at home as well because vinegar is 30% acetic acid.
Ah,
White vinegar.
I never knew that.
Depends how strong you need it to be.
It doesn't stipulate, but it's all about the electrolyte reaction. So
Well, white vinegar, if you can't
white
find
vinegar.
the acetic acid stock.
might be a good way to go. I'll be back shortly.
Okay, cool. So what's in here? We got one board each. Is that what's going on?
Yeah, it seems so. We got the same parts, and we've even got two screwdrivers, which is convenient.
Oh, okay.
Yeah.
It's almost like someone had planned that out.
See,
Here in the background.
yeah, she's a bit of a wizard. So we've got to attach the little, what are they calling them?
Awesome.
Isolation columns with some screws. This kind of reminds me of those like little builder men you can get from the grocery store
Oh yeah.
when you spend a lot of money. They're a bit of fun.
Or some Lego ones.
No, there's like little cardboardy ones.
Oh yeah.
They're good that they use cardboard now for those little giveaways, the little
No,
plastics.
that is good.
Hi. Yeah.
We've been-
I'll use vinegar if I have to, but you know if Fiji has any.
Yeah,
This is our
so
little
These little things with the screws. You're going to need two
Acid?
screws and two of those, and we screwed it from the bottom.
Okay. Oh, it's
Vinegar is acetic acid.
Okay, so we need. Are these both the same? I think they're both the same. As we've realised with studying street science, two pieces can look very similar, but then be completely different. So we need it in the one. It's this one.
That
not-
doesn't have the little cutout.
Oh yes, there is a cutout. Okay, cool. Okay, and that goes over here. Check that one. Goes in here.
Or is it the other way around? It's the other way around. No,
Right.
it's right.
That's good.
See, this is what you mentioned about the instructions not always being perfect, right? In the diagram, they've showed us one that doesn't have a cutout on one end. Right, so
Oh yeah,
here I can see you've got this one's got this little cutout at the end and this one doesn't. So on the diagram here, we've got no cutout and they refer to it as board one. But then in this part, the one they've referred to as one has a cutout.
Okay.
So I'm going with the step-by-step instructions.
Okay. That sounds good.
Yep.
So install. I see. Install the other one on the other side.
Yeah. So you're getting both of your white columns in. We're putting both of our verticals in. It's sturdy timber, this. Well, it's ply, I think, but it's going to make quite a sturdy frame.
Yeah, cool. Let us know in the comments how your day is going. We'd love to know what's been happening. Is this chaotic as our day? It's busy. We've been very, very busy, very productive. All right, so when we're building in the framework, so we put the sides in, it looks like.
Mine was a big day. It was a good day, though. I got to go to a vacation care and do a workshop for them.
That's
And it
cool.
was actually really, really fun.
What was the workshop you on?
We did rocket. CO2 rockets. Yeah, using the centrifuge tubes and then that citric acid baking soda reaction. It works really well.
So you were using acetic acid. So like
Or citric acid.
oh, citric.
So another acid. But if you were to try to launch rockets at home, you could actually use acetic acid. So vinegar works really well, like that old volcano experiment.
Oh yeah.
Yeah, acetic acid would do the same job.
Interesting.
Alrighty. So
Okay.
I flipped the page on you, Ken. Are you catching up?
Yeah, yep.
Beautiful.
Try my best. All right, so we get that in there, and then what's this on?
Putting this little vertical one in.
Oh, and back in. Okay.
Yeah, I can't see a difference end to end.
Yeah, okay, so that fixes in there. Yep.
Right, and then we do screw fixation. Oh, we put the top board on and do it. Oh, and that's where the cutout comes in. I see. Right, when I line this one up.
Your hypothesis was correct to go with the pictures.
Yes. Otherwise, we could have just put it on that end.
Okay, so you fix that one on there. I wonder where Jono's gone. Hopefully,
Still looking for acetic acid.
he's gonna be quicker than I would be if I was trying to find acetic acid. Because everyone knows that Ken at Street Science doesn't know where anything is.
Well,
That's why they don't put me out the back.
this is why you're the on-screen talent.
So that fits on there. Yeah. Okay.
Yeah, that clicks in nicely, and then we fix that with a screw.
Hey,
Hey, he returns.
We found him. No one worry. We had comments furiously happening down below saying where was Jono?
Your people were worried.
I got lost, guys. I had to go down into like the third level basement to find the ingredients that I was
Yeah.
after.
Yeah. You didn't use the shortcut here?
I didn't.
You didn't do the shortcut?
No.
Is the lift
Is there
still
a
working?
The lift working? Let's try that again. Let me just try it again.
Had I have known, I could have gone down all 3 floors on the Kinder.
Ren, come back.
Oh
There we are.
Yep. Oh,
You're so cringe.
secret trick.
So cringe. All right, so we're tightening that there.
All right, are we enough of these? So we put these through here. I'm just making this up now. You know how Ken likes to go off script sometimes with these toys.
Yeah, but you'll probably end up finishing it faster than I would with my attention to detail.
Okay, yep. So we're turning it there, and then we're adding the orange things.
Yep, so we're fixing those 2 screws there to
Oh, we
tighten that top
I'm
down.
missing the screws. Okay.
Yep, then a couple there. I think we dropped one somewhere along the way.
You're
I'm
up.
adding on these little stoppers.
Yeah. So I reckon if we've got a clock and we've got cars, and we've got 2 cars.
Oh, we could time our racing.
Yeah, yep.
Time trials.
Or we set up maybe we could set up a street science track adventure.
Sounds like
I
that
don't know
needs
how
a
that would
theme
work.
song. Street Science Track Adventure.
We're gonna get a sting, mate. What is it? Did yours go in here? Mine just feels like it's really loose in there.
Did
Did
you
I
put
forget the actual thing?
did you put the little white thing in there?
Did I? Let's find out. I feel like I might break it. So I'll go through this one. Well, that one went in.
I can see it. Yeah.
It's just not going in. Okay. I don't think it's necessary.
Just twist it a little while to make it grip. Goodness, you and I are very different with our interpretation of
Okay,
instructions.
no, it does go. No, we're good. We're good, guys. We're good.
It's all sorted.
There'll be one spectacular car, and then one car that's just has a bit of character.
It's just along for the ride. Thank you. Yes.
But we definitely need to get Jono's commentary here more often in the studio.
You mean my terrible puns?
Yeah, I mean, like it's just
I'll let
it just
anybody
comes so
can
natural.
get the terrible puns. They just need to read the side of a cornflakes box.
It's just like it's just so natural. It's just like seamless. I'm impressed. I'll tell you what. I'm a little bit jealous.
Just don't get John and I started in a science joke off because it's not good for anybody involved.
I mean, are you laying down a challenger?
We already know each other's material.
Yeah, no, we've
But not everyone else is on the screen. Okay, let's test it out.
Oh no.
Really?
Jono was famously told off by a young girl in school saying, "You're only embarrassing yourself, mate." It was quite cutting.
Hello to Wish Heart States if you're watching.
Do you remember who it was? Is it?
She was awesome.
She was so great.
She was
They were
really cool.
such nice kids.
Oh, that's cool.
And they didn't like my jokes at all, and I still like them.
Oh, okay, fair enough.
I like them
I
more
like your
because
jokes.
of that.
So be prepared. Be prepared. If you've got Jono coming to your school, there will be laughs aplenty.
Bad jokes. That's not laughs aplenty. That's groans aplenty.
Crickets. All right. So I've inserted the shaft and I've attached the fixing
So
things.
you put both orange things up.
Yeah, I'm not sure how tight we put them though. Whether we still want those wheels, like the shaft, to be able to rotate or not. So I've done mine quite tight. So maybe you do yours looser,
Well, do you
and
move
we'll
the
compare.
orange things back near the wheels or something? No, it says
Well,
in there. Okay.
I feel
Just
like
the whole thing in there. Okay.
now I've got the wheels on. They don't really seem to be rotating. So I think you want it to be a bit further away. It's just to stop it from falling out, I
So
think.
they just pop onto it.
Yeah, they seem to just attach to the ends. I'm going to loosen that little fixing washer.
All right. Strip that one in there. Strip that one in there.
Yeah, much better with that looser.
How's the clock going, Jono?
It's taking a while. I'll admit I have never built a saltwater clock before.
Oh, really?
In fact, the concept of a clock is quite unfamiliar to me. Could be why I'm always late.
That's not going to help then. Nowhere in the instructions did it said throw the car on the ground.
Can't take it anywhere.
We found it. It's tests durability test to make sure.
Are you going to need a timeout, Ken?
Yeah. Thank you. I can't be left alone. I'm not even left alone in the studio. I'm here with other people. I still can't. I'm theoretically being supervised, and I still causing chaos. Okay.
May I?
Ooh,
I'm
yes.
decorating my car.
Oh, yeah, here we go. We do have some color textures hidden under the table, which is perfect. I was actually using them earlier for a video, and I was painting my nails. True story. But I did clean up because I knew that everyone was going to be checking my
I can see your cuticles.
hands for this show. I didn't want to distract you from the amazing science of my colorful fingernails. So this magnet goes on the outside, right?
Correct.
Okay, it's going to go there.
So as Jono tested earlier, we're going to have the same pole facing towards each other.
Okay.
So they should. Well,
And that's going to let us know in the comments. What do you think? When they're the same pole facing each other, do they attract or repel? Let us know. We'll see who's the people that have been thinking about it more harder than
more harder.
More betterer.
More betterer.
I'm pretty sure that's how it works. More
The betterest.
All right, I'm gonna put some. What do you think I should put on mine?
Well,
I
mine's
feel like I need some pink there. We get some. Or are you gonna do like some color contrast of green and pink. 'Cause that's pretty
You
cool.
can use the pink if
Oh,
you
you-
choose to.
You got lightning. What's
Mine's
fast?
called green lightning.
Green lightning. Okay. What's faster than green lightning? What's faster than lightning?
Not much is faster
Um,
than the speed of light.
All right. So we're doing a pink light. Here we go. Pink sun all coloring.
Now this has become craft time.
Yeah. Okay.
Not very good at lightning bolts.
Here we go.
Mine got a bit weird.
Did you put the name on it?
Thickened it out. Let's get going. How you going over there, Johnny? Do you need me to fetch you anything else?
I'm not entirely sure. I think I've got all the ingredients I need. I just need the fine motor skills to be able to put it all together.
Yes.
Can't give you that, sorry.
Yeah, you're facing the problem that I normally have. You've got the screwdriver as well. It's pretty. You need to get the magnetized screwdrivers where it's where the action goes.
These ones are pretty good.
Pretty nifty for an included screwdriver.
It's just become craft time with Jess and Ken.
All right. What do you reckon? What should we call it? Let us know in the comments. What do you reckon would be a cool name for the fastest car?
Oh,
That's
really?
clearly faster than speed of light, faster than the speed of light.
I think yours is called You're Dreaming.
You're dreaming. All right, it's cool. I like that. Oh wait, don't use orange. Orange one's a bit meh. I'm gonna get a. What else we got? Green. I guess we got green.
The blue seems to bleed.
Cool. That's the.
Check this out. And the type of timber we've got here, right? We've got some clear marks where the colour has actually bled through the timber. I'd say that's capillary action.
Oh, which would be. Is that a type of force? Oh, no,
Well, it would be something in the timber is applying a force because it is making it move. So,
or to do with surface tension. Then.
I'm trying to remember my capillary action sort of stuff. It's not quite a vacuum, but it creates a pulling force. I think it's about like diffusion because you'd have like lower concentration further up the capillary. Remember that old experiment with putting celery in coloured water?
Oh yeah, I remember doing that one.
Sucks it up.
Yeah, that's a cool. We should do a do-it-yourself experiment. I reckon that'd be pretty cool.
There's a really good one I know actually about that. You can do with celery, but you can do the same thing with paper towel.
So how does that one work?
So you fold a bit of paper towel into like a long shape and you bend it over the top with 2 water glasses. And you'll have, say, one red and one yellow. And then through capillary action, the water gets drawn up through the paper towel. And then when it reaches the top, you'll actually see it start to mix. So you get orange at the top.
So you get some like cool color mix.
And you can use all 3 primary colors and have like 2 bridges of water in between them. And you can sort of make all of the tertiary colors. It's very cool.
I like that experiment. I reckon we should definitely do that and then see how everyone's going. But all right. I think our cars are ready. How's the are we up to?
Well, I'm getting a bit of a bum steer from the instructions we can.
Okay.
It's telling me to combine my acetic acid and my salt in the cup on the left and stir well. And it doesn't say anything about the cup on the right. So this is a bit of a chemistry challenge for us all. Because what we're talking about here is electron transfer between zinc and copper.
Yeah.
We have, if we have a look close up on here.
Let's move this out of the way.
We have a copper contact and a zinc contact. And the electrolyte movement is such that one will more easily and more readily give up its electrons than the other and allow an electron transfer between 2 materials. Okay. The salt water is going to actually work as an electrolyte in this case. And the acetic acid, I believe, is going to cause a caustic or acidic reaction to the metal, which will actually make the electrons disperse.
So does the electrons transfer from one side to the other?
That's right. And they will actually transfer through the clock depending on how we wire it all up. Where I'm confused is whether I start my whole process with the acetic acid and salt combined or whether they are independent, because the instructions definitely imply that they need to be combined and stirred well.
And the other cup should have plain water in it.
Is that what it's saying there?
Yep. Pour water into each of the 2 cups and then add acetic acid and salt to the cup on the left.
Right. All right.
Okay, well,
Instructions,
I'll need to
my
find some
friends.
water.
that's why we have Jess and Jono here.
I'll be right back.
I've got
Oh,
some
that
more.
would be a.
Here's some I
Can I
prepared
use
earlier.
The delightful jungle.
Here we go. Check it out.
We need 40 mils of water in there. Lovely.
Okay. Well, it's pretty cool.
Not precisely measured, I will be honest.
Okay. So one side has plain water.
Plain water.
The other
The other
side.
side will have some salt water and some acetic acid.
Okay.
Again, it doesn't really say in the amounts.
Okay. And what we're
So
expecting
40
is.
mils of water and acetic acid and salt.
Okay.
So
So
I've
it's-
already pre-mixed some salt water up here.
Okay.
So I was thinking that probably to be a bit gung-ho about it, I was just going to probably take about 10% of that salt water out and
Mhm.
add my vinegar.
Okay.
And that should actually be able to create some sort of electron flow from there.
Okay. So you need another container.
Yeah.
Here's one I prepared earlier.
I could use my teacup, but that would be very
Ah, yes, perfect. Okay, cool. All right. So we're doing a little bit, keeping a little bit of the salt
yeah.
water in there.
Yeah.
And then
Now
this
that's
is
a, that's a
acetic acid.
hypersaline salt water that I've stirred up.
Yeah. And then
And
this
that's
is
just
acetic acid.
that's just ordinary. That's actually just
Or is that the water?
household vinegar.
Oh, it's household vinegar.
Because as Jess suggested, acetic acid is household vinegar is about 30% acetic acid.
Okay, cool, awesome. So we're gonna. What's the percentage ratio we're going with? We're going.
Oh, well, that's 30% acetic acid. It doesn't even talk about the purity of the acetic acid, but I'm assuming if this is available for home usage, we're not going to be going out and buying acetic acid in its purest form.
Okay.
So to get it as a double strength vinegar is probably the best way to go.
Okay, I'm thinking that we should definitely record the volumes because if it doesn't work, then we can.
Yeah,
figure
that's
out how to
actually a very
troubleshoot.
good idea. All right, so what I'm doing here is I've got 25 mils of salt water.
Okay.
And I'm going to top it off with 15 mils of acetic acid.
Acetic
So I've
acid.
got a total of 40 mils.
Okay, so viewers at home, write that down for us. We're really prepared scientists here. We have our notepad and pen, but we don't need that when we've got you guys at home.
There's my titration.
Now, I would like to shout out some of our watchers that have been diligently watching each show. And I know, I think it's CM. I'm not sure what your first name is, but I want to give you a shout out. Thanks for saying how amazing the show is. We really appreciate it. All right, so we put our lids on, and we're expecting the electrons or the ions, the electrons transfer between one side through the other, and then through that create some type of electrical current or some type of energy.
Flow of
That would then-
electrons.
Flow of electrons
Flow of electrons.
that would then activate the clock and make it work without batteries. So
I heard a
that's-
great saying about electricity is electricity is just really the flow of electrons from a negative place to a positive place, which is really what we're all trying to do.
Now, I don't mean to blow my own horn right now, but can we pull out KenCam, please?
Oh,
Because
KenCam.
currently
KenCam
my
here,
clock
we're good.
tells us that it is midday or midnight, which
Let's chuck this
is
over here.
probably right for me.
But it is working. So no batteries installed. We are
Yeah,
simply
it's
using.
not a
Over
battery.
here so that we can see it. Let's see. Is KenCam working? We're waiting for him to work. Here we are. I'm just going to turn him off and turn it back on. Hopefully he turns on. If not, we might have to try and do some like cool juggling.
I can juggle.
Oh
Not
no,
the
KenCam's not
chemicals.
working.
Don't juggle the saltwater clock.
All right, hold on,
You'll
let's
make
try
a
again.
mess.
KenCam's not the most reliable cam.
While you're
Just
getting
like
KenCam going, I'm going to hold it up so we can see on the other camera.
Yeah, shall I hold it up? I'll hold it up high to
Right,
the camera.
here we go.
Oh,
Beautiful.
yeah, I was waiting
Meanwhile, the
for
car's
that.
trying to get away. 1, 2, 0, 0.
So, because before it wasn't working, should we just do the control where you take it out and does it stop?
Absolutely. It will absolutely.
Whoop, hang on, I'm going to tilt it up.
Okay, so
I'll
get
be in
that
charge
here.
of tilting. You can do
Okay.
the honours of pulling out one of your
Right, so tilt it a bit more. Can you
electrodes.
tilt it a bit more? So we can see
Electrodes, is that what we're
Oh,
talking
there we
about?
go. Okay, you can
Yep.
see the numbers there.
So I'm going to remove
Yes.
Hey, check that out. It was like instantaneous.
instant power.
Because electricity relies on a continuous circuit.
A complete circuit.
Ah.
That's right. So we have a flow of electrons going through there. Now we should be able to even set the clock. I'm going to set the clock and see if I can put a timer on this so we can
Oh.
actually do a race.
It would be cool if there
I
was
think
a
it
timer.
is a simple classic digital.
So if you want to know more about what's happening there, I believe the sort of key concept you should look up would be redox reactions.
Redox reactions. All right.
Yeah,
Everyone at home, redox reactions.
redox.
you'll be sorry.
REDOX, meaning reduction oxidation. So you've got the two different
Okay.
processes happening at the same time.
Now what I've got, I've now changed the clock to a simple timer.
Oh, you actually have a timer?
I have a timer on it.
Okay.
And it currently reads 38, 39,
Oh,
40.
it's
So it's
ticking
just
on.
going to tick through the
Okay.
minutes.
All right. So now let's
Whee!
check out our magnet cards. As you can see, these cards have no batteries whatsoever. The only thing that's moving them is the power of magnets. And as we said before, each magnet is pole to pole, negative to negative, positive to
I'm
positive.
not quite sure. Yeah, just like poles.
Like poles together, and that means they can't join and they repel each other. And that makes the first one push the second one
Without touching.
I love
when the wheel works.
Hey, look,
And that's
three
my one too.
wheels- 3 wheels is better than 2.
Okay, let us know in the comments which car is faster and looks more cooler.
Looks more cooler.
Which is the coolest? Who's got the coolest? So, what do you reckon? Should we set up a little obstacle and then time it and then wrap things up?
Yeah.
Absolutely.
How do we set up a little obstacle? I feel like we've got a box here.
Can we make it a ramp?
What about with
Using
using
a rapid radar?
And this like, oh, here we go.
Yeah, that's perfect.
Hey, check that out.
And we'll use some UV beads as a little obstacle to get around.
Pull this one down so the camera can see it.
On out, yep. There we go.
Bend
This
it out of
one-
shape a little.
And this one underneath.
Is that going to work? All right, I'll hold it. I'll let you guys.
Did I catch you doing something with UV beads for like a STEM club or something recently?
Oh yeah, we were playing with these things. These things are super fascinating. These beads, and if you're interested, you can get some on our online store. They change color when they're exposed to ultraviolet radiation, which, if you don't know where that comes from, it comes from the sun. And it's the same type of energy that can burn your skin. So if you ever get burnt, which hopefully you never do, but if you do, the reason is the UVB, the ultraviolet radiation, is hurting your skin and causing that inflamed, red, nasty reaction. And that's why it's really important to wear sunscreen.
Yes, indeed. And interestingly, good tie-in because that UV light is part of the electromagnetic spectrum, which magnets are also a part. It's the same type of energy.
There you go. That's science. It's all circular. All right. So what are we going to do? We're going to put the cars up here.
No, I reckon we start at the bottom
Oh,
and we've got to maneuver.
Into the
We've got to maneuver around the beads and into the box.
Let's do it. All right. Where's our timer at? It's
I've got it here. Now, what's the best way for us to keep this timer going? Shall I just say ready, set, go when we're at a certain point?
yeah. Let's
And
just
then I'll just give you the time.
how quick it is. Okay.
I
Cool.
mean, I've got a reliable and pretty efficient source of energy going on here. So I have all faith in this clock not losing a second.
Okay.
All right, so no, you tell us when to go, and then
Go for it.
and then we'll
All right.
tell you when to stop.
I don't know how to turn it. Turning's going to be
This is
tricky.
going to be tough. All right, I'm gonna start you guys. Going to start you, Jess, on 45 seconds in 3, 2, 1, go.
Okay, don't know how to turn the car. Hang on.
Oh wait, here we go.
Oh,
We use the power of magnets.
Hey, see what I did there?
Very smart, very smart. Oh, he's got the stuff.
Sounds to me like what we really need is strong.
Oh, get up there.
Here we go. We're gonna try that.
Oh, something's happened.
Here we go.
Okay, this ramp is not very strong. I mean, sorry, this
Oh,
is.
the magnets are strong. It's
Ramp game.
So,
yeah, let me start him up. I'll start him up there.
yeah, all right, let's see.
Is he strong enough?
Well, I just got to make sure that the poles stay immediately facing each other.
Okay.
Because what's happening here is they're connecting to the back side of the magnet. So it's
Right.
attracting rather than repelling.
Oh, balance it out. Yep. Here we go. Here we go. Oh, what was it?
Yeah, 52 seconds.
Minus 45.
Minus 52. No, I was
Oh.
counting from 52 seconds all up.
Okay.
Now, shall we re-ramp this one for you, Ken? Because this is not a fair fight right now.
Or are we going to retire?
Let's
From the sport.
retire our
I think
magnetic
we're
racing
retire.
because it's not a great sport. I gotta say, I prefer to watch, I don't know, lawn bowls.
Yeah. What is interesting, we've been looking for a timer for our show to count down 30 minutes of each show, which I'm pretty sure we've blown out. How long are we at? We're at 40 minutes now. So maybe we use this clock in the future. Very, very scientific as well, which is pretty rad. So
Now, what will be interesting too, Ken, is maybe next episode you can tell everyone how long this battery actually lasts for.
that is a really fascinating question. Let us know in the comments, how long do you reckon this clock will last? Based on those acetic acid and salt water alone. I mean, it's going to be fascinating to see. So maybe we'll even try and set up a time lapse of some sort.
And which
we
will
have to
last
measure.
longer, the battery or Jess's entertainment in these cars?
That's a big question.
That is quite quick.
All right. Well, I think we should wrap it up. Thank you so much, Jono.
Okay, oh, well, thank you, Ken.
Thank you so much, Jess.
Thanks.
I'm pretty sure we had some seriously fun science.
We did.
We will be back next week, as always, 3:30 p.m. Australian Eastern Standard Time for Study with Street Science. We will see you next time.
Bye.
Bye, everyone.